Okay, just tipping sample 1 into the tray. Just take my little filter out there. Sample 2 now into the tray. Okay, and sample 3 into the tray as well. The other thing to remember is we're doing these experiments with the sand at room temperature, roughly 20 degrees, and that's not what happens in real life on a dog track. The temperature obviously is going to be variable according to the weather, anything between about -5 or perhaps a bit lower up to 30 degrees or even hotter on a summer's day with the sun on the sand. And that has a big effect on the quality of the water. We don't tend to notice that the viscosity of water changes quite dramatically with temperature. It's quite a lot thicker and gooier at around about 4 degrees than it would be at 30 degrees. In fact, it's half as viscous at 30 degrees as it is at 4 degrees. And that's going to change the way the sand develops, and it may be one of the factors as to why tracks behave so differently in the hot weather. It's not something we notice in our day-to-day life when we're using water, but it is actually quite a dramatic effect. So let's just see how sample 1 handles now. Still quite crumbly. You can't get that to really form into a ball there. It fragments quite easily. We'll just try compacting that down. Again, it's actually quite difficult to compact that sand down. Okay, sample 2. Again, fairly crumbly, probably compacts into a ball slightly more easily. Again, it does tend to break up a bit as you squash it down there. Okay, sample 3. This is our medium sample of sand. Again, doesn't really form into a ball very easily, crumbles quite easily. They're actually, just on this very crude test, seem to behave in quite a similar way. Probably, as you compact that down, you get a slightly better surface perhaps, but it is very hard to tell the difference. We probably need to do this on some bigger samples. You're asking a lot with a greyhound track, really, because you need 2 different properties of the greyhound track. Firstly, you need a bit of give as the paw hits the track, so that some of the shock of the weight is absorbed and not entirely transmitted through the leg. So for instance, as the paw lands on the surface, I'm just going to simulate that with my hand now. On a hard surface, the full force has to be taken up by the leg, and as the paw hits, you find that what happens is, on the front leg for instance, the wrist sinks down like that, and the springiness is taken up in the ligaments that run down the back of the paw here. So it puts quite a lot of strain on those ligaments. As that joint is moved further and further in that direction, you get force on the front of the bones here, and that's what accounts for some of those carpal fractures that you get there. So that's a feature of a very hard surface. The softer the surface, the more the paw will sink in, and the less force there is on those tendons. Now, when the paw is taking off, when the paw is actually launching the dog into the next stride, you need the surface to not slip. As weight is put back onto the paw there, you need no give. You need the dog to be able to predictably put his paw down and the paw not to slide. Likewise, when the dog is going around a bend, you don't want the paw to slide in that direction, because again, that's another cause of injuries. So that's 2 quite different properties you need from the same piece of sand. You want it to be hard in that direction and that direction so that there's no slip, but you want it to be soft in the vertical direction. Now, unfortunately, that's the opposite of what tracks are, because on the surface of the sand, as the paw hits, the sand underneath supports that surface sand and makes the surface quite hard, whereas in this direction, there is very little support from the sand either side, so it's very easy for the paw to slip sideways. So whatever you do with a dog track is always going to be a bit of a compromise because of that, so the way the sand works there on the surface. But we'll come back to that in a later video. All right, thank you then.